Hey there, science enthusiasts! Welcome back to another deep dive into the fascinating world of quantum mechanics. Today, I'm diving into a mind-bending question that has puzzled many and continues to baffle even the brightest minds in physics. Does an electron really actually spin? This question might seem simple at first glance, but it opens up a whole can of quantum worms. Let's unravel this quantum mystery together. Buckle up, because we're about to venture into the strange and wonderful world of subatomic particles. First off, when we talk about electron spin, we're not talking about it spinning like a tiny planet. Unlike planets, electrons don't have a surface or a shape that we can see. Instead, spin is a quantum property, a fundamental characteristic of particles like electrons. It's one of those intrinsic properties that define what an electron is. Imagine it as an intrinsic form of angular momentum. But unlike the spinning of a top or a planet, this angular momentum doesn't involve any physical rotation. But wait, what does that even mean? How can something have angular momentum without actually spinning? In classical physics, angular momentum is something you can see, like a spinning top. You can observe it, measure it, and even feel it. However, in the quantum world, things get a bit weird. The rules of classical physics don't always apply, and we have to think in entirely new ways. Electrons are point particles. They have no size and no surface to spin on. This is where our classical intuition fails us. So, how can something without a surface have spin? This is one of the many paradoxes that quantum mechanics helps us understand. Here's where quantum mechanics comes in. It provides a framework for understanding these strange properties that don't fit into our everyday experiences. Spin is a type of intrinsic momentum that's not about physical rotation. It's a quantum property that exists as part of the electron's identity. It's a fundamental property like charge or mass. Just as an electron has a certain charge and mass, it also has a certain spin. Think of it as a built-in feature of the electron. Sounds strange, right? But this strangeness is what makes quantum mechanics so fascinating. Now let's get even more bizarre. The concept of spin leads us to some truly mind-boggling ideas. Electrons exist in states described by quantum numbers, and spin is one of these. These quantum numbers help us understand the behavior and properties of electrons. They can have a spin quantum number of +1, 2. This doesn't mean they are spinning up or down in a classic sense. Instead, it's a way to describe their quantum state. It's a shorthand for understanding how they behave in different situations. And here's the kicker. Their spin affects their interactions with magnetic fields and other particles. This is where the concept of spin becomes incredibly important. Picture this. When an electron's spin is aligned with a magnetic field, it's in a lower energy state. This alignment can have significant effects on the electron's behavior. When it's anti-aligned, it's in a higher energy state. This difference in energy states is crucial for many technologies. This is crucial in technology like MRI machines and even the basics of chemistry. Understanding electron spin helps us develop and refine these technologies. So, does an electron actually spin? The short answer is no, not in the way we imagine. But this doesn't make the concept any less real or important. The short answer is no, not in the way we imagine. But its quantum spin is an essential part of its identity and how it interacts with the universe. This intrinsic property is key to many of the electron's behaviors. Quantum mechanics might seem like a rabbit hole of weirdness, but it's these strange properties that make the universe tick. Without them, the world as we know it wouldn't exist. Thanks for joining me on this quantum journey. I hope this exploration into the nature of electron spin has sparked your curiosity and wonder. If you enjoyed this video, hit the like button, subscribe, and let me know what other quantum mysteries you'd like to explore. Your feedback helps us dive deeper into these fascinating topics. Until next time, stay curious, keep questioning, keep exploring, and never stop being amazed by the wonders of the quantum world. Until next time, stay curious.